How to make single phase induction motor self-starting. To make single phase induction motor self-starting, it is temporarily converted into two-phase motor during starting period by connecting starting or auxiliary winding to the main winding. So making single phase induction motor self-starting. Here running winding and starting winding converted into running winding and starting winding. Two-phase motor. Running winding and starting winding, two different types. Split phase motor, resistance start motor also. This is the capacitor start motor. Resistance start motor, capacitor start motor. How to make single phase induction motor self-starting. How to make single phase induction motor self-starting. The two windings are spaced 90 degrees apart, connected in parallel. Phase difference between the currents through the winding is nearly 90 degrees. Then a rotating magnetic field is developed. It can be explained by any one of the following two ways: by double revolving field theory, by cross field theory. Stator given single phase supply, only alternating flux produced resolved into two components. The two components are phi F and phi B. So one magnetic field rotation like this, two magnetic fields rotation like this. Equal and opposite forces are creating here. Here producing north and south poles, a sine wave. Phi F and phi B are equal magnitude. Phi F is equal to phi B, rotating in opposite directions at synchronous speed. Phi F in anti-clockwise direction, phi B in clockwise direction. And phi R is the resultant of phi F and phi B. Here. two in one direction. One is rotating in clockwise direction, one is rotating in anti-clockwise direction. At every stage, the magnitude of the two components, phi f forward, phi b, phi backward, are equal in magnitude. So here double field revolving theory, phi f and phi b is equal and opposite, then the resultant force phi r is equal to 0. Phi f is equal to phi b, that is equal to phi 1 by 2, phi 1m by 2. Here, if both are in one direction, stator field and its two components, so double field revolving theory, alternating magnetic field setup. The resultant flux is alternating in nature only, but not rotating. This alternating flux acting on stationary rotor cannot rotate the rotor. That's why a single phase induction motor is not self-starting. Each flux produces its own torque. Phi F produces TF torque. Phi B produces TB torque. TF and TB are equal but in opposite direction. So net torque is 0. This is the double field revolving theory. Torque speed curves for both the component. Upper one is the forward field, lower one is the backward field. This is the resultant torque. Resultant torque. How to make the rotor to rotate? The relative motion between the stator flux and the rotor is needed. So, to create relative motion, the rotor is given in an initial start in either direction, then torque in that direction increases. Torque in that direction increases, giving the performance similar to three-phase induction motor. A rotor rotating in stator pole. This is the animation. The rotor conductor slightly cued to eliminate the magnetic locking. Okay. Coming to the conclusions, at standstill, the forward and backward torques are equal but in opposite direction. So net torque on the rotor is zero. So single phase induction motor is not self-starting. When rotor is given an initial start by some external means, the resultant average torque increases in the direction of rotation. Motor gives performance similar to three-phase induction motor. So what we have discussed, construction of single-phase induction motors, working principle of single-phase induction motor, and a double field revolving theory. Okay, double field revolving theory we have discussed. Okay, so coming to the quiz on this topic, single phase induction motors, the stator flux resolved into how many components? One, two, three, sorry, none, three or none. So stator flux resolved into two components, forward and backward. Forward and backward. Two components of stator flux are option A in the same direction, option B in opposite direction, option C none. Two components of stator flux are option A in the same direction, option B in opposite direction, option C none. So two components of stator flux are in opposite direction. In opposite direction. One is called forward flux, one is called backward flux. Forward flux, backward flux. Does each flux produces its own torque? Yes, no, none. Does each flux produces its own torque? Yes, equal and opposite torques. So, own torque not equal, opposite directions. The resultant torque is a sine wave. We have seen it, double field revolving theory. So, each flux produces its own torque. Double field revolving theory is based on the idea that pulsating field produced in single phase motors can be resolved into two components of dash its amplitude and rotation in direction with synchronous speed. Double field revolving theory is based on the idea that pulsating field produced in single-phase motors can be resolved into two components of dash, its amplitude and rotating in direction with synchronous speed. Option A of same, option B of opposite. So double field revolving theory is based on the idea that pulsating fields produced in single phase motors can be resolved into two components of its magnitude and rotating in opposite direction with synchronous speed. With synchronous speed. The direction of the two torques are option A same, option B opposite. The direction of two torques option C none of them. Opposite direction. Direction of two torques are in opposite direction. Opposite direction. In a double field revolving theory of single phase induction motor, the slip of forward motor is S, then the slip of backward motor is option B 2S, sorry, option A 2S, option B yes, option C 2 minus S, option D 2S minus 2. In a double field revolving theory of single phase induction motor, the slip of the forward motor is S, then the slip of the backward motor 2 minus S. 2 minus S. So by combining 2, then we will get 2. 2 minus S is S equal to 2. When a single phase induction motor is excited with single phase AC voltage, the magnetic field setup is option A two fields rotating in opposite direction with different speeds, two fields rotating at synchronous speed in opposite direction, two fields rotating at synchronous speed, two fields rotating in the same direction but at different speeds. So two fields rotating in opposite direction with different mode. Two fields rotating in synchronous speed in opposite direction. Yes, it is correct. Two fields rotating at synchronous speed but in opposite direction. Two fields rotating in same direction but in option B. When single phase induction motor is excited with single phase AC voltage, the magnetic field setup is two fields rotating at synchronous speed in opposite direction. Two fields rotating in opposite direction with different speeds. Two fields rotating in opposite direction, okay, with different speeds. Two fields rotating at synchronous speed, I think so. I think option may be B. in the operation of an induction motor is based on option A, Lenz's law, option B, Ampere's law, option B, principle of mutual induction, option D, principle of self-induction. Induction motor works with the principle of induction. So, principle of self-induction or principle of mutual induction motor. So, mutual current passes in the stator winding, flux cuts the rotor winding. So, principle of mutual induction. Okay, that's why induction motor, also called as short-circuited transformer. Transformer also works with the principle of mutual induction. So current produced in one coil, the flux cuts the other coil. So here the flux produced in stator and the flux cuts the rotor. So principle of mutual induction. Single phase induction motor is option A self-starting, option B not self-starting, option C starting with the help of auxiliary winding, option D none of the above. Single phase induction motor is not a self-starting, so starting with the help of auxiliary winding. So not a self-starting, but we can make with self-starting with auxiliary winding. Okay. So at the time of starting, we will convert single phase induction motor into two phases. One is auxiliary winding, one is main winding, starting winding, running winding. Single phase induction motors are used in large number due to option A, their great variety of useful service in home, office, factory, business, establishment, and on the farm. Their wide applications in automatic control devices, lowest cost, both A and B. So single phase induction motors are used in large number of due to their great variety of useful service in home, office, factory, business establishment, and the firm. Okay, their wide applications in automatic control device also correct. So both A and B also correct. In a single phase in a single phase induction motor, stator supplied with single phase AC, rotor supplied with single phase AC, rotor cage type, rotor wound type. In a single phase induction motor, stator supplied with single phase AC, okay. Rotor supplied with single phase AC is wrong answer. Rotor is a cage type winding is correct answer. Rotor wound type. So cage type rotor correct answer. Stator supplied with single phase AC also correct, but temporarily we make that single phase AC into two phase AC by providing phase shifting between these two windings. That may be resistance one, that may be capacitor start, capacitor one, split phase. So what may be the technique? We will convert that single phase into two phase. Okay, both answers are A and C are correct, but C is the exact answer. Single phase induction motors are more noisy than three-phase induction motor because of inherently low power rating, squirrel cage rotor design, pulsating electrical power input, and constant mechanical output. So, pulsating electrical power input. That's why they are more noisy. Pulsating electrical power input. The rotor slots in an induction motor are usually not kept parallel to the shaft as it helps the rotor teeth to remain under the stator teeth. It helps in reducing the tendency of the rotor teeth to remain under the stator teeth, improve the power factor, improve the efficiency. Option B, help in reducing the tendency of the rotor teeth to remain under stator teeth. In comparison to three-phase induction motors, single-phase induction motors have option A low efficiency, option B low power factor, option C poor speed regulation, option D more slip at full load, option D all of the above. In comparison with three-phase induction motor, single-phase induction motor have low efficiency, low power factor, poor speed regulation, more slip at the full load, all of the above. Performance characteristics of a single-phase induction motors are dash that of the three-phase induction motors. Option A satisfactory as, option B less satisfactory than, option C more satisfactory than, option D almost as satisfactory as, so less than satisfactory. The power factor at which single-phase induction motor usually operate. Option A 0.7, option B 0.8, option C 0.87 lead, option D unity. Generally, it is a lagging 0.7 lagging. So three-phase, it's a 0.8 lagging, single-phase 0.7 lagging. The motor built-in fractional dash horsepower sizes are technically termed small motors. Answer true or false question. The motor built-in fractional horsepower sizes are technically termed as small motors. Answer true. In single-phase induction motor, if rotor is initially given a start by some external means in either direction, the motor will run in that direction. Yes, it is true. Electrical fractional horsepower motors are usually dash in phase type. Option A fractional horsepower single phase type. Option so it is a filling the blanks. Answer single phase. The rotor construction of a single phase induction motor is identical to the three phase induction motor. Three phase induction motor. The rotating part of the single phase induction AC motor is called rotor. The squirrel cage winding motor is usually placed in the dash slots of the armature rotor. In a single phase induction motor, the starting torque is zero. Starting torque is zero. So, for one phase induction motor, how many stator windings are there? One phase induction motor, how many stating windings are there? Two windings. Single phase, but two windings. Starting winding and auxiliary winding, main winding. Is one phase induction motor is self-starting? No. What is the type of flux produced? Pulsating or alternating flux? What type of rotor is generally used squirrel cage rotor. So coming to the assignment, compare the working principles of three-phase induction motor and single-phase induction motor. Draw the squirrel cage rotor of induction motor. List the merits of squirrel cage rotor over other types of rotors. Frequently asked questions. Explain the construction of single-phase induction motors. Why single-phase induction motor is not self-starting. Write the working principle of single-phase induction motors. Okay, thank you.